Great. I guess Aditya is here, so I guess we can start off. Asmi, if you want to introduce the speakers. Yeah.
Thanks, Asmi. Uh, Hi guys. So let's start off with our session today. Um, uh, do you guys have any idea like what topics we can cover or we should cover today? Am I audible, everyone? Give me a minute, guys. Yeah. So sorry for the disturbance. Let's start off. Let me share my screen first. I hope my screen is visible. Can anyone confirm? Okay, guys. So there are some topics that I will be covering right now, and then there will be some topics that will be covered by Aditya. So let's start off with very basic concepts that are very important in machine learning. So first comes is like mean, median, mode. In machine learning, so we are very familiar with these three terms and these three terminologies that we have covered in our normal maths classes in class 8, 9, 10th. Kind of like it depends from school to school. So like during that phase we have already covered what mean, median, mode is. But today let's look into how mean, median, mode helps in machine learning. So firstly comes mean. So what is mean? It's like kind of brushing up, we are like brushing up what we have learned in our past in our maths, so that it's like easier for us to interpret what like how it's helping us in machine learning. So when it comes to mean, mean is like also known as average, is the sum of all the values in data sets divided by the total number of values. And it in machine, when we talk about machine learning, it represents the central tendency of the data. Now comes what is central tendency. So central tendency is the statistical measure that identifies a single value as a representative of the entire distribution. So when we have a very large data set, so there's a very we actually when we want to refer that data sets, we actually represent it as a one single value, which is a central tendency, which is like the mean value or the median value. It aims to provide an accurate description of the entire data. It is the single value that is most typical representative of the collected data. So this is what central tendency means. So when we talk about mean, it represents the central tendency of the data, and I guess that is very obvious when we talk about the mean, because it's giving us the average, so it can be considered that it is representing the central tendency of the data. Then when we talk about median, median is the middle value of the data set when it is ordered from least to greatest. So if when we talk about machine learning, when we talk about median machine learning, and when we are using the median function, it actually automatically arranges the data set into least to greatest, and then gives us the median value. We'll be further looking into it as well. So if there's an even number of values, it's the average of the two middle values. It's the robust measure of central tendency and less affected by outliers compared to the mean. So people who are very new or very beginner to machine learning, they might not be knowing they might not be knowing what outliers are. So outliers are basically when we are dealing with any graphical representation and we draw a line, like a basic line, like mean or median line, we can say, like a basic line to differentiate between the data. But there might be some data which is like very far away from the data that we are that we the most of the data is like, let's say we are having 100 of options that we are representing on any kind of graphical representation that we are doing from that for that 100 options or 100 outcomes. But there's only one data which is having as let's say that number or that probability of that data is 999, and the other 99 data set is of like let's say around 40 to 50, like let's say it's 42, 43, 55, 60, 70, kind of like it's like mostly between 1 to 100, and there's just one data which is triple nine. So when we will be having a graphical representation of it, so that particular point, when it's like we will be having a scatter plot of out of that data, so that particular data set will be very far away from what we are dealing with, which is like the other data set. So that particular point or that particular scatter point will be considered as a outlier for this particular data set. So this is what the theory is written here, the similar what I have explained just now. So an outlier is a data point that is significantly different from the average value of a group of statistics. For example, in a graph with dots, an outlier will be a dot that is far away from the other dots. An outlier is someone or something that is very different from the other people or things in a group. So let's say we are having kind of data of car, so like we are having different companies of which are into car sector. So it's like we will be having a data set consisting of all those things, and let's say we have one particular company which is dealing into food and beverages. So it will be a very obvious thing that this is not considered in this particular company should not be considered in this data. So that particular data can be considered as outlier in this case. So this was a very basic example. So he had not stood out as an obvious outlier within the party. So when we are talking about any food and beverage company, so it's not it's not obvious that it will be belonging to the car sector, right? So it's like very obvious. The company is an extreme outlier in terms of both its pricing and behavior. The factors can be different as well, depending on what data you are dealing with. So this is what outlier means. So when we talk about medians and mean, so it's like mean gives us it's like more central. When we talk about median, so it's a robust measure of central tendency, which is less affected by outliers compared to the mean. So when we talk about mean, so mean is actually taking out the average value. So it's like more affected by the outliers. But when we talk about median, which is taking out the middle value, so it is less affected by the outliers. So I guess this concept is clear to everyone. Can you guys write on the chat if you have any doubt? Or you can just guys can write yes if you are clear with these concepts. Okay, let's deep dive into the session then. Okay, so then we talk about mode. So mode is the value that appears most frequently in the data sets. It's like basically checking the frequency of a particular data in the data set. So a data set can have one mode, more than one mode, which is termed as multimodal, and no mode if all values occur with the same frequency. So in conclusion, mean is the average value, median is the midpoint value, and mode is the most common value. And I hope you are clear with what outlier is and what central tendency is. So here's the uh, code to calculate mean, median, and mode. So here we are importing NumPy, and then this there is this scientific Python, we can say, this library, and importing stats from it so as to calculate the mode. But when we talk about mean and median, we can calculate it by NumPy library only. So we are here creating a sample data, which is this, and then we are actually using NumPy, and we are using this operation dot mean, and we are specifying our data in the brackets. And here similarly for the median. But when we talk about mode, we have to use stats here, so that to calculate mode. Let me run this function, this code. So here you can see we are getting the mean, median, and when we talk about the mode, so it actually creating a object mode result, where it is giving us the count of the particular data which is occurring more than one. So here we can see that 18 is occurring for three times in the data set. So it's creating an object mode result, and it's giving us output as that when we talk about the data mode 18, it's the count of that particular data is 3. So this is how this three operations work in machine learning. And yeah, when we talk about median, so if there are two numbers in the middle, or we can say there are the number of data in the data set is even, we divide the sum of those numbers by 2. So when we are dealing with even numbers in the data set, so it's not even numbers, like the data number of data present in the data set is even, so then we are dividing the sum of those two numbers which are coming in middle by 2. So let's talk about what's the usage of mean, median, and mode in machine learning. So when we talk about mean, we have already learned that when we talk about machine learning, mean is like for data pre-processing, normalization, and imputation of missing values. So what is normalization? So normalization is a scaling technique in machine learning, which is applied during data preparation of to change the values of numeric columns in the data set to use a common scale. And it is required only when features of machine learning models have different ranges, or it is used whenever the attributes of the data set have different ranges. So when we want to concise the different ranges which are already existing in our data sets, so we are actually using it, concising it to between 0 to 1. So when we do all these things, we need to use the mean operation as well. So in machine learning algorithms, features are normalized to have a mean of 0 and a standard deviation of 1, which helps in improving the convergence and performance of the models. I hope this is clear, and it helps to enhance the performance. And yeah, basically it's like when we are concising the data sets, we are cleaning out of a data set. So it's like it's improving the performance and reliability of the machine learning model that we are creating. And when we talk about imputation, so imputation is basically when we are dealing with any kind of null values in the data set, when we are actually doing pre-processing of the data set, which is like cleaning of the data sets, then we are actually we are actually dealing with the null values as well, and duplicacy as well. So when we talk about mostly when we are dealing with the null values, what we do is we actually replace the null values with the mean values. And I hope you guys remember when I was taking the last session of pandas, when we were talking about the cleaning of data set, I have actually done the same, that I have replaced the null values from by the mean values of the salary column that we were having. I hope you guys remember that. So similarly, that particular thing is considered as imputation. So you can just read out here that missing values in data sets can be imputed using the mean value of the feature, especially for numerical features. And when there's the third point as well, which is evaluation. Mean is often used as a metric for evaluating model performance, such as mean squared error (MSE) or mean absolute error, which is MAE, for regression tasks. So these two things are very very important we are evaluating our model. And actually we will be learning about these two things in detail later when we will be covering linear regression, polynomial regression, all those topics. So we will be discussing these two topics in detail when we will be dealing with all those topics. So for now you can just be assured that we are using a mean for evaluating the models as well. Further, when we talk about median, so we have already learned that it is very less sensitive to outliers compared to the mean. So basically the main usage of median is for dealing with the outliers only. When we are dealing with outliers, we actually use median. We prefer median more over mean. The second point here is robustness to outliers, which is similar to what I have just explained. Skewed distribution. So, what is skewed distribution? A skewed distribution is a distribution that is not symmetric or normal. So, when we are having a graphical representation of any kind of data, so I will just try to explain this in words. Let's say we have a graph where one side is very lower, which is like nearer to 0 to 1 in the y-axis, and the other side is up till let's say 99 or 100 in the y-axis. So it will be having a graphical representation where the one side is very lower and we have a very kind of change in the slope will be very high, and we have kind of having a change in the representation from like very low to very high. So in the one side, the representation is very high, and the other side the representation is very low. So that type of graphical representation is basically known as skewed representation. So in though that is also considered as asymmetric representation as well. So in a skewed distribution, data values trail off more sharply on one side than the other. So this is known as skewed distribution. So when we talk about median, so median is often used to summarize skewed distribution where the mean might not accurately represent the central tendency, as there is a very asymmetric representation. So when we are taking mean of that data, that is not very much efficient when we are dealing with data. So that's why we actually take median of that data, which is quite very quite good, or quite better. It provides us better results as compared to mean when we're dealing with skewed distribution. I hope all these concepts are clear to each and every one of you. Let me know if there's any doubt in the chat section. Mode, so mode is basically very easy than mean and median. So mode is like it represents most frequent value in the data set. We already have known this. And when we are dealing with categorical data, or categorical data is like what are the we are, let's say we are having 100 of categories. So what are the categories having most of the data set? So we can deal with that just by taking out the mode of the whole data that we are dealing with. So the number of the frequency of the data will actually let us know that which category is having most of the data. And then accordingly we can analyze our results accordingly. So it's basically the process of data exploration. So basically mode helps in category to deal with categorical data and helps in data exploration. So these were the three very basic topics of machine learning. And let's dive into the other topic, which is standard deviation and variance. So when we talk about standard deviation is a number that describes how spread out the values are. It measures the average distance of data points from the mean. Let's say we have actually calculated the mean, and we want to see what the other data that is remaining from the other data that we are having in the data set. So we want to see like what's their deviation from the mean, like what's the distance between the mean value and the data that we are dealing with. Let's say we are iterating through the whole data set. So that particular data is the distance of that particular data from the mean values. This is known as standard deviation. So standard deviation can also be considered as a square root of variance. So we are currently we will be having explanation of variance as well after the standard deviation. So you will get to know about this. So a low standard deviation means that most of the numbers are close to the mean, because like if the distance is low, or the standard deviation is low, which means that the numbers are close to the mean value or the average value. And if there is high standard deviation, which means that the values are spread out over a wider range, or we can say that it's like the data that we are dealing with is like a higher standard deviation actually indicates more dispersion in the data. Like the data is very scattered. That's why we are having a high standard deviation, which means the distance of those data is very high or lengthy, and then from the mean distance from the mean. So it's like comparison when we do. So if it is like the date, if the standard deviation is more than one or kind of that, so it's like very high and if it's like under the one range, it's like considered as a very low standard deviation. So let's deal with a very basic data. So let's say we are importing numpy here, and then we are uh, taking out the mean of this data. So we are taking speed as 86, 87, 80. So you can see that the numbers that we are dealing with in this data set are very close to each other, which is 87, 86, very close to each other, and 88 as well. So those data set we are that kind of data we are taking right now, and we are taking out the mean. So here you can see the mean is 86.42. And now we are taking out the standard deviation of it. So how we can take out the standard deviation is simply by importing numpy and then using dot std operation and then specifying about what data that we are dealing with. So here we are dealing with speed. As of here you can see the data here is speed, and then we are importing it into the std operation, and then we are printing out what's the conclusion of it. So here you can see the standard deviation is 0.9, meaning that the most of the values are within the range of zero point 0.9 from the mean value, which is 86.4. So here when you are taking out, you can directly take out the standard deviation as well. I hope you guys know when we were in the last class when we were dealing with uh, data visualization, and before that we were dealing with how we are going to describe our data, what are the information that we can take out from our data. So we have actually used np.info and np.describe. I hope dot info and dot describe functions there, which were actually describing what is the mean value, average value, and count of the um, data that we were dealing with. And there also we were having std, where I have actually explained you what standard deviation was, which is like the mean from uh, the distance from the mean. So it's like a similar thing that we are actually implementing by just applying that directly into the code. So you can also use that dot describe or dot info for taking out from your taking out the standard deviation from your data. But if you're dealing here we are dealing with just one data set, which is this, and we are taking out their standard deviation by just using dot std. So this is how we actually do standard deviation. We take out the standard deviation. But as you can see here, we were actually dealing with a data set where the data were very close to each other. So let's now dig into a data set where the values are very much fluctuating and are very opposite to each other. Let's say here we are dealing with two-digit number 32, and here in this data set we also have a three-digit number, which is triple one. And similarly we are having a mix of data of two digit and three digits. So let's take out the standard deviation of this particular data. So just to showcase to you what is the mean value, here I am taking out the mean value first, and then I am taking out the standard deviation. So here you can see that the standard deviation is 37.84, meaning that most of the values are within the range of 37.85 from the mean value, which is 77.4. So as you can see, a higher standard deviation indicates that the values are spread out over a wider range. So it's, I guess it's very obvious when you will be representing all, this data in the a graphical representation form, which is x and y axis you will be taking and just representing using a scatter plot or any kind of graphical representation that you want. So you will get to know that the data is very scattered. So this is just for knowing what kind of data you are dealing with. Then we talk about variance. Variance is another number that indicates how spread out the values are. Variance measures the average squared deviation of each data point from the mean of the data set. So here the value will be squared actually from the mean of the data set. So indicates how much the data points vary from the mean. In fact, if you take the square root of the variance, you get the standard deviation. So like I had actually discussed this in the standard deviation as well, that it is square root of variance. So when we want to switch from variance to standard deviation and from standard deviation to variance, so it's very easy, that simply you have to take out the square root of variance, you will get the standard deviation. And when you are switching from standard deviation to variance, you have to simply multiply standard deviation from itself, and then you will get the variance. So there's not much difference between standard deviation and variance, but yes, we will. I guess you guys are a bit confused what standard deviation and variance is. Like why it's like very similar. Variance is just the square of the standard deviation. Like the distance is just squared from the when we're taking out the distance from the mean. So what's like basic use of variance when we were already having standard deviation? Like those questions might be in your mind, so, of course, we will be answering that question further in the session. Firstly, let's look into how we are going to calculate the variance. So, here we are having the same data set, which was the a bit scattered one, which is 32,111 we were having in the data set. So, firstly, let me take out the mean of this. So, you already know we have taken out the mean of this data set, which was 77.4. So, when we talk about variance, so how we are going to do this? Firstly, we are going to take out the mean of the data set, which is 77.4. Then for the each value, we have to find the difference from the mean. So we have already taken out. You can see the difference when we have taken out. It is in negative form as well. So for each difference, we are actually we are actually squaring them. So it's like we were having minus 44 45.4, so we are doing square of it, so we will get 2061.16. So similarly we are doing for all the data set, and then the variance is the average number of these squared differences. So we were taking out the average of this data sets. Similarly, we are going to take the average of the data set after doing the square. You can see that here we are taking out the average, which is 1432.2. So this will be considered as the variance. And when we were dealing with simply the mean, so we were simply just calculating the mean by taking out the average. Okay, so I hope you guys are clear with this concept. Let me know if you all have any kind of confusion or doubt in this particular topic. Any doubts, everyone? Okay, no doubts. Okay, it's very good that you guys are clear up with the concepts being discussed right now. So yeah, so simply further, when we talk about variance, what we can do is, of course there are various methods to apply this particular steps that we are when we are dealing with variance. But simply what we can do is we can use dot var operation to take out the variance of the whole data. Like when we talk about this whole step, so firstly we need to take out this mean, and then we have to subtract it from the mean value. We have to take out a loop and iterate to the data set and subtract it from the mean value, and whatever outcome will be there, we have to take out the square of it, and then again take out the mean of all the new data set that we are having. So all the steps can be done using continuing to this particular code, which is like we are firstly taking out the mean, and then of course we will apply a loop or whatever concept you are thinking of, you can do that. But to simplify all those things, we have already have a operation known as dot where when we are dealing with numpy. So we can simply um, actually inform our just add our data set to the dot var function, and then we will be having the variance of that particular data. You can see the variance is similar 14332.2. Here when we are calculating, here is the same, and when we are taking using the function or the operation, then we are having the same result here. So let's see when we are dealing with both of the things, which is variance and standard deviation, how we can do. So here we are taking the very simple data 10, 12, 14, 16, 18. And when we talk about variance, so simply dot var dot var and the data that we are dealing with. And when we talk about standard deviation, what we can do is just taking out the square root of the variance. As I have already mentioned, that standard deviation is square root of the variance, so simply sqrt operation you can use and take out the standard deviation of this. So you can see that the variance is 8 here, and the standard deviation is 2.828. You can take out by using pen and paper and calculating all these things, and you will get the same result as well. You can, after the session, you can check everything. When we talk about how they are different to each other, standard deviation and variance. So standard deviation and variance are two key measures commonly used in financial factor. And standard deviation is a spread of a group of numbers from the mean, and the variance measures the average degree to which each point differs from the mean. Here's to just you can just have to focus on this thing, that its average degree to which each point differs from the mean. While standard deviation is the square root of the variance, variance is the average or squared difference of, like, the simple same thing that we have already known. So the two concepts are useful and significant for traders who use them to measure market volatility. Example, an investor makes sure that he has a firm grasp on how to calculate and interpret standard deviation and variance, so he can create an efficient trading strategy for the same. So you know that when the traders are dealing with graphical representation of how the stocks are moving upwards and downwards, they are actually want to predict the future as well, future of those stocks as well. So they can do that by, also they actually use these two terminologies, which is standard deviation and variance as well, to do so, which is a very deep thing. If you are creating any model out of which is dealing into stocks, and it's like giving us the output, and it's predicting the future, or if the stock will go upwards and downwards, kind of that model you are creating. So of course you will need standard deviation and variance to implement that model. So the next topic is permutation and combinations in machine learning. So we already you guys might already know what permutation and combinations are. Like we have already dealt in our in our maths classes in class 8, 9, 10. So it's like very obvious, but here we'll be just brushing up the ideas. So permutation is basically selecting the data or objects from a certain group, and a permutation is an arrangement of object in a specific order. So let's simply look into the picture. So when we are dealing with a data which is a b c, so we are actually looking into the arrangement of what are the different arrangement that this data set can be considered. There is a data set having three data, which is a b and c. So what are the arrangements, different arrangements this data set can be arranged. So that will be, firstly we'll be taking a, in the first place we might be taking b, in the first place we might be taking c. And when we are taking a as in first place, then b might be in the second place, or c might be in the second place. So these are the two possibilities. When we are taking b in the first place, there might be again two possibilities. When we are taking c in the first place, again might there will be two possibilities for the other left two data. So these are the basically when we talk about permutation. So permutation is basically dealing with the arrangement of data set. So when we talk about permutation formula, we already know this is the permutation formula. And when we talk about combination, so combination is a selection of object from a larger set without considering the order. For example, there are two components A and B. Then there is only one way to select two things, which is to select both of them. So when we are talking about permutation, we are looking into the arrangement of the data, and when we are talking about the combination, which is simply to select the data. So let's say we are having A, B, C. So there are only three possibility to select this data, which is A, B are being selected, B, C are being selected, or C, A are being selected. So when we talk about combination, when we select A, B, which is considered to same or similar to B or A. So we are not taking other possibility of B, A here. But in permutation, of course, we were taking because we were dealing with arrangement and not with the selection. So here, if B is already selected with A, we are not going to select it again and taking B, or we are taking B at first and A and last. So that is not considered as a selection. Selection here means that what kind of data you are combining and taking as a selection. So here we are already taken A and B, so we won't be taking again B and A. So this is known as combination simply. Here here's a a very much theory, a deep explanation of each and everything, so that you are clear with the concepts. You can just go through with all these things after this session. Here's the formula of the combination, and here we are using iter tools. What is iter tools? So here's the Python iter tool is a module that provides various functions that work on iterators to produce complex iterators. This module works as a fast memory efficient tool that is used either by themselves or in combination to form iterator algebra. So when we talk about iter tools, so it's like you already know that we are actually, if we want to let's say we have having two lists, and we want to multiply those the elements of the two lists. So we can achieve that by also using loops, or what we can do is we can use the map function as well. So when we talk about iter tool, so iter tool is a module which actually helps us to reduce the time and reduce the memory as well, because when we are dealing with loops, you already know that the memory and the uh, memory memory usage is very high, and the speed also reduces when we are dealing with loops. But when we will be dealing with iter tools, so it will be working as a very fast it will be working very fast, and it will be also helping us to reduce the memory usage. So that's why iter tools are actually providing us with those operators, or those libraries which is like very good, which is like operators, or like whatever we can say, the functions that we can use to deal with the data, and which are like you, so that we can reduce the memory. So here you can see from iter tools we are importing permutation and combination, and then we are having a very simple sample data, which is 1 2 3, and then we are printing permutations first, and for that we are having a loop to iterate from all the data, to take out the permutation from iterating from the data set that we are having. So for perm in permutations, we are printing out the perm. So here you can see the permutation will be 1 2 3, 1 3 2, and the other will be, we will be taking 2 at the first, so 2 1 3, or 2 3 1, or 3 at the first, 3 1 2, 3 2 1, similar to the ABC representation that we were looking in the above. And then we talk about combinations. So here we will be having two loops. First one will be the for first one we will be defining r in range 1 to length data plus 1. Can you guys know like why we are having length data plus 1 here? Can you guys answer this very simple question? Anyone in the audience? Okay, so let's move further. So, when we talk about here length data plus one, this is because we want to consider the last data in the data set as well. That's why we are adding plus one to it, because when we are defining the range here, it does not include the last value. It exclusively takes the range when we are here. So that's why we are adding one to the length of the data. And for further, we are actually taking out another loop with where we are dealing with the same data of and that range will be up till r. So here's the basic explanation of the same thing. In when we are dealing with permutation, we use permutations function from the iter tools library to generate all possible permutation of the sample data. Each permutation represents a unique arrangement of the elements. And when we use combination function from the iter tools library to generate all possible combination of the sample data, and we iterate over different values of r. The size r here is the size of the combination to generate combinations of different lengths. I hope that is clear. And simply here you can see we are having seven combination out of the data that we have given. So here it will be also taking the null values, because when the r is having in the r is in the index 0, so the combination will be having no index that time. So that's why it will be printing null here. So simply it will be having 1, 2, 3 as a individual combinations, and then it will be having 1 2 1 3 2 3 1 2 3, and like that this will be the seven combinations out of the data that we have given to it. So here's a basic difference between permutation and combination as well. So when we talk about permutation, the definition of permutation is an arrangement of all the members in order, and a combination is a selection of members from the collection or group. Represent Permutation represent arrangement, and we talk about combination, it represent selection of the data. The order in the permutation, when we talk about order in the permutation, values are arranged in an order, but when we talk about combination, values are not arranged in any specific order. When we talk about arrangement in permutation, order of arrangement is important, because we a b and b are two different combination when we're dealing with permutation. But in combination there is no specific arrangement which is required, because a b and b a are considered same combination in combinations when we're dealing with combination. And when we talk about the usage of permutation, so permutation is used when different kinds of things are to be sorted or arranged, because we are sorting different things, so we are also taking out what kind of things are going with what kind of things. So it's like as we are dealing with different combinations here, so that's why so when we are dealing with different kinds of things to be sorted or arranged, then we are looking into permutation. And when we're dealing with combination, it is actually used to deal with the same kind of things that are to be sorted or arranged. So I hope you guys are clear with the concepts covered till now, which are mean, median, mode, and then we dealt up with standard deviation and variance, and then we have like brushed up with permutation and combination as well. So I hope you guys are clear with all the topics that are covered till now. From now on, Aditya will be taking up the session and will be covering the other topics as well. If you guys have any doubt, you can just drop your doubts or queries in the chat section. We'll be dealing up with them after the session. Over to you, Aditya.
I'm audible.
Yeah, you're audible.
Okay. So, hey guys, hello, my name is Aditya Shaw. So, further on the discussion would be taken by me. So, let me share my screen first. Can you guys see the screen? Okay. Asmi, is the first slide visible? Yeah. Yes, yes. Thank you for that. So guys, we are having percentiles in our first discussion. So let us understand what is percentile. So basically, if someone asks you what is the percentile, you can answer that percentile is just a value that describes the values from the data set which are lesser than that particular values. So suppose your friend gave an exam and he comes up with a result of 95 percentile. So the 95 percentile means that your friend is in above position from the 95 percentage of the people who gave the exam. And suppose you came up with 100 percentile, so it means that you are above 100% of the total population who gave the exam. So let us understand this from the example also. So here we have a data set ages which have random data from 5 to I guess 82. 5 no 2 to 82. 2 is the least value and 82 is the highest value. Okay, so suppose someone asks you what is the 75 percentile. So let's discuss it and calculate it. Here the answer is 43 obviously, but how it came, let's think and let's uh, come to it. So here we have the original data set is of 21 size and it's an array, and it is not in sorted form. So first we need to calculate the data in the sorted form. So here we have calculated the data in the sorted form. I have indexed it from 0 to 20. You can index it in your way also, as it is for the understanding purpose. So we are calculating the index of the 75. No, not 75. Let me check. Yeah, 75 percentile. So what we can do is we can put the percentile here. So let's see. We make another variable index 1, and we just write the 75 here and divide it by 100. Then we need to multiply this value with n minus 1. So what represents n here? N is the total number or the size of array or the total number of values given to you. So n here is 21. So 21 minus 1. So this equals to 3. 75 by 100 would be 0.75 and into 20. So if we calculate this value, so this values comes with 15. Okay, so it gives us the index of 15. So we go and check in the array, in the sorted array, what's the value lies in the index number 15. So here we go here. So it is the index number 15 and corresponding to that the value is 43. So here we got to know about how this percentile works. So we can also take another example like index 2, and suppose someone gives you the someone gives you any percentile like random 90, and want you to calculate the value that is in the 90 percentile range. So you can just do it by same, just multiply the same thing, and here we have 21 minus 1, and that's equals to 0.9 into 20. uh, yeah, that equals to 20. So here the no, not that, not equals to 20. Yeah, that equals to 18. So yeah, here the index number we got is 18. So we come up with the index number, the value which are there in the index number 18. So here it is 61. So 61 would be the answer. So like this percentile works. So here I have written a program also for you to check the percentile of this data set. So let us run this program. Just copy it and second. Yeah, just go to the. Yeah, I'm using Jupyter Lite for running my programs. You can use any Python compiler you are familiar with. There's no issue. So here comes it, it's come 43. So it is the answer. And if we change the data set to suppose 50, let's see what happens. So it comes 31. So 31 is the value that comes under the 50 percentile. So now if we change the data set to 100, let's check the value 82. So 82 is the value that comes under the 100 percentile. Obviously, why 82 came, you all know, like 82 is the highest value, and 82 is the highest value means 82 is above every value in the data set. So it comes 82 here. So now let's discuss another thing, distribution. So data distribution in real world, what happens? There are big data sets given. Not this much of values are given to you, and someone will ask you to calculate the percentile. There would be a huge data set. Suppose 10 lakh, 1 lakh, 10,000, any numbers, it can be there. So to create those data sets, we need some functions in Python. So how we can represent those data set is being understandable under this category, data distribution. So how to create those big data set? Like first we will create an array of 250 random floats, and 0 to 5 you can take any data type you want. If you want to take integer, you can take integer also. There's no issue. So let us do it by a Python program. So here I have written one program that imports the NumPy module. If you don't know the NumPy library, you can check out our videos in our YouTube channel that is hosted by, I guess, Tisha and Ashmi. These guys have explained NumPy and Pandas library very well. So you can also check that. So here we have imported the NumPy first, and we are using the numpy.random.uniform. Random means we are generating random values from 0.0 to 5.0, and these values are there are 250 values. Okay, uniform means the difference would be uniform from 0.0 to 5.0. There would be a uniform difference among the values. Hmm. So let us first copy this program and check. Yeah. So see, uh, there are different values we came up with. There are this much amount of values, like there are 20 to 50 different values we came up with, and these are all random values. So anyone uh, in this session can answer if I change this value, if I run this code in your computer, and or you can run this code in your computer, these values would change or this value would fixed. Anyone in the chat can answer it. Like my question is, if this code is run by you in your computer or in any other computer, will these values change or will these values would be fixed? Yeah, Khushi has answered well. So we are using random function. It's a basic general knowledge. We are using random function here. So the values would definitely change. There would not be any fixed amount of values. But yeah, the amount of values would be same, 250. It will generate 250 values. So here we understand the data distribution, how it occurs. Now let's move on to histogram. What is histogram? To visualize the data set, we can draw a histogram. So suppose let's take this example. This amount of values are given, okay, and now you want to visualize this amount of values. So it would be very difficult to you if you can't draw any figure or any visuals of it. So the understanding part and the analytics part would not come from without drawing any visuals from this. So histogram is the same. It draws the visual for the data, and from that we can assume or we can predict the outcomes for the future, or for the outcomes which can be used by us or which can be used by a company, organization, anyone. So these are like bar graphs, plots, scatter plots. These are all the visuals that we are seeing on the screen that represents the data, so that it can be more understandable and it can be more analyzable. So it is just that. So here a program I have written for the histogram. So how we can draw a histogram? So I have imported the NumPy library here. You can do in two ways: import NumPy as NP, and you can use the NP convention to np.random uniform this way also, and you can do the direct way also. So I have used the direct way here, and I have imported the pyplot module from the matplot library to plot the histogram. So it is used to plotting of bar graph histograms and all. And we are generating 0.0 to 5.0 float values, that is float values from 0 to 5, and we are generating 250 values here, and we are plotting this on a histogram. So plot dot hist means we are using hist function, means we are making a histogram from this program. So x is the variable which we have used here, and 5 is the here 5 is the indexes of this histogram, like the difference, this one and this one here, 0 to 5. So I can zoom it well. Yeah, you can see 0, 1, 2, 3, 4, 5. So the histogram indexes are from 0 to 5. So we are given 5 here. So plot dot show means we are, if we want to show it on our screen, so we need to call some function. So we are using show function here to show this data on our screen. So let's just copy this code and run it in our Jupyter Lite, and we can see, yeah, we can see a histogram representing this amount of data. So there are 250 data which are represented by this histogram. Further, I would explain what is the range of the data, like what data lies from where to where. So let's just change the value. Let's just make it 25, and let's see what happens. So see, the histogram becomes smaller and the values in the y-axis becomes lesser than the previous. There previously there was 50, I guess, and it is currently 8. So we can just do it in that way, and we can, if we put 105, the histogram would change like that only. So it's just a representation. My point of view is just say to make you understand, like histogram is just the representation of the data set which you are given. Okay, so is there any doubt regarding histogram and the topics we discussed? Like if you are having doubts in histogram data distribution, or the first topic percentile, you can ask. What do we learn exactly from histogram? Okay, like in terms of data distribution. Okay, how does it help? Okay, so let's answer this question. So here we can learn that there are some amount of values which lies from 0 to 1, and these amount of values, what is the amount of values? We can see that it lies between 15 to 20. There are this much of amount of numbers that lies from 0 to 1, and we can infer that there are 1 to 4, there would be the values range, the number of values are same from 1 to 4. So we can infer that there are the same amount of values lying from 1 to 4, and these amount of values are given in the y-axis. This can be greater than 20, it can be 25 or 29, anything, but it would be greater than 20. That can be inferred from this histogram. Like this type of analytics we can draw from our histogram. I hope it is clear. Okay, so is there any further questions? Okay, okay, got it. So let's carry on the discussion to the next. So like this, I want to explain the histogram from this part. Like if that question wasn't encountered. So like see, we can see the 52 values are from 0 to 1. 48 values are from 1 to 2, 49 are from 2 to 3, and 51 3 to 4, and 50 values are from 4 to 5. So here we can see that in the first, we need to change it to 250, and we Yeah, see, like I have shown in the PPT, 52 values. So it shows means greater than slightly greater than 50. Okay. And 48 values from 1 to 2. So you can see 48, it is in this range only 1 to 248. So like this, and 50 values from 4 to 5 like this we can see the we can draw this much information from our histogram, and we can further draw more information from the histogram as well. It depends upon the data set we are using. So we if we are using random data set, so random data set wouldn't provide much information. It just provide the x-axis y-axis values, and you can just infer. And because the x and y axis particularly doesn't represent anything age or marks or anything, so we cannot say anything about the data. But if the data set is more informative, so yeah, we can say that this amount of marks is received by this amount of student. So yes. So yeah, this question was asked by me previously, and one person answered it very well. So will the array values would be same in every computer? Obviously not. We are using random function, and the random function generates random values. So there would be a random value set. So it wouldn't be same for every computer. So let me check if you have any questions. Okay. So let's carry on the discussion further. Uh, let's see big data distribution. So in real world, 250 values are not big enough. Yeah, it's understandable. Like 250 values are very small in data science or in machine learning. So what we can do is let's create a data set of 1 lakh. Yeah, 1 lakh random numbers and display them using a histogram with 100 bars. So the bars would be 1 to 100. Yeah, this amount of bars would be there. And the numbers would be 1 lakh. So we are generating this number from the range 0.0 to 5.0 as same, and we are using the numpy library here as same, and we are using pyplot module from the matplot library as we had imported it, and we are using plt as our convention. PLT is just used for convention, like PLT is acting as a, you can say, not variable, but it is acting convention. So if we don't want to write this thing matplot dot pyplot dot these whole things everywhere, so we are using PLT, a short form of it, so we can use it conveniently. So now we are having x as a variable that is storing the numpy values from 0 to 5, uh, and it the amount of values are 1 lakh. There would be 1 lakh values, and we are plotting in the histogram, and we are representing x to 100 here. Means first value start from 0.0. It can be anything from 0.0, and we are using show function to show the histogram. So let us run this code. Okay. Yeah. As there are 1 lakh values, it will take, yeah, it is generated. So yeah, here you can see that there are 100 bars here, and it represent random values, and here is the amount of values. Like if this values is from 0 to, I guess, 0.1, so this much amount of values are lying between 0 to 0.1, like it can near to 1000. So these are the amount, and these are the actual values. X represent the values, and y represent the amount of values near to that. Okay, we can change this as well. If we can do with the 10,000, the histogram would change like as well. Yeah, histogram becomes more clear, and we can observe a pattern here as it is a random value. So I guess pattern, saying pattern is not a good keyword here, but we can, yeah, we can observe and draw some amount of information from that also. So if we change it to 100, let's see what happens. Yeah, you can see the histogram changes. Like there are no values in this range, in this range, and in this range there are no values. So it's a random function, so it is generating the values like the compiler or the interpreter. It is generating the values on its own. So we can't do, or we can't say to generate that particular value. It is generating on its own. So there is no inference of us. We what we can do is we can change the parameters here and see the result what's happening to the data set. Okay. So till here, is there any question? Can you zoom in a little in the notebook? Okay. If you are saying in the this portion, let me, okay. Yeah. Now you can see. Yeah. Okay. Any question? Do you have? Yeah, anyone, I'm asking to all, not the particular person. Okay, no doubts. Okay, so let's carry on further. Uh, So we have done this, and we have checked the histogram how it works. So let's continue to new topic, which is normal data distribution. So normal data distribution is just like the other data distribution. So what happens? The normal data distribution curve is very unique curve. So here you can observe a bell-like shape in the curve. Like in every data set, if you do normal data distribution, you observe a particular bell like shape here. Like the data set would be, yeah, different for any person or any organization data you are using. It can vary, but the shape of the graph would be same like this, a bell like structure you can observe. So let's understand what is it. So how to create an array where the values are concentrated around a given value. So it means clearly that normal data distribution uh, means uses of the data which are concentrated around a singular value. So here the singular value is 5. You can observe, if you draw the line for a 5, so you can observe a peak value 5 here, and all the values are around 5 only, not is there anything not going beyond 5. So the values are occurring in the range of 4 to 6 only, so it is covering the range 5. So from this we can know, like, if we are generating the normal data distribution, so it concentrates its graph or any visuals around that particular given data set only. So here it is given by the famous mathematician Carl Friedrich Gauss, and whose name is very famous. I think if someone knows mathematics deep, he also knows this mathematician also. So let's observe this normal data distribution with an example Python code. And here we can run this code. After running the code, I will explain the code. Let's run first. So here you observe a bell-like structure like I mentioned earlier. So see here, 5 lies here in the middle of 4 and 6. So you can observe the top part at 5, okay? And the rest of the parts are concentrated around 5, isn't it? Yeah. So what we are dealing with the code is we are similarly importing the NumPy library, which is very important. If someone doesn't know about NumPy library, I would suggest go and watch the videos of the NumPy library to understand it. So we are having the matplot library, and we are using the pyplot module as the PLT as a convention. So we are generating 1 lakh values from 5, and here it is the mean value 5, and it is the standard deviation value. It is not like the previous one, the starting value, ending value, and the number of values. The first value represents the mean value here, because we are using the different normal function here. So first is the mean value which we want to describe, and second is the standard deviation, and third is the amount of value which we want to generate. So we are using histogram. So we are having the histogram method here, x to 100, and x represent the variable, and show function to show our histogram. Let us manipulate the values a little and see the change in the graph. Yeah, you can see that particular structure which was starting from, let me first zoom out. Yeah, You can see the graph has changed a little bit. It starts from minus 2.5 and it goes to 12.5. And if we are putting 1 as a standard deviation, let's see what happens. So you can see the range has changed. It starts from the positive number and ends to up to before 9, I guess. Yeah, before 9 it ends. So this is something like which we can understand the normal distribution, how it works. So it concentrates about the given values. Here the given value is 5. So let's change this value to 6 and see what happens. So you can see 6 becomes the middle value here. 6 is the most concentrated value here. Like around 6 every values would revolve. I want to say that only. If you want to change this 6 to suppose 9, let's see what happens. Yeah, let's see, the middle point is changed to 9. Like if you draw a centered line from here, you get 9, and the other values are concentrated around that. So this is what normal distribution is. It is concentrated about a particular values and gives the result as same. So yeah, any doubt you guys have in the normal distribution, or any doubt with the code which I shared? Okay, okay, let's move on further. So here we have scatter plot after the normal distribution. So what is scatter plot? Let's understand. Scatter means anyone can say the meaning of scatter. You can use any chat GPT or anything. I don't have problem. Just you can say the meaning of scatter. Like what do you mean by scatter? Like the word. Yeah. The position are at random. Yeah, it can be. Not so fixed. Okay. Yeah. Anyone wants to say something about scatter? Any other person? Okay, no issues. So yeah, Khushi said right. It is the positions are not fixed. It is scattering like air particles, and we can see that here. Like scatter just means the data sets have random values and it is scattered around x and y axis, as we can see in this visual. So we have here we uses two type of arrays x and y. X represents here the age of each car. It's an example. You can take another example for your understanding as well. I am taking it as it I found it very simple to understand. So y as array that represent the speed of each car. So if the if someone says you the age of the car is 15 years, so the speed would be generally lesser in for that car. And if someone says that age of the car is 1 year, so speed would be very fast because it is new and the its mechanic is very new to the environment and it hasn't gone through the frictions and all. So it's very understandable. So let us draw a scatter plot using these two arrays. Let's first copy this code and let's run this. Okay. Let's see what happens. Plot. So let's assume. So here we in the y-axis we have the speed and in the x-axis the age. The age of the car is 12 and the speed is less than 80. The age of the car is beyond 16 and the speed is, yeah, it lies between 85 to 90. Okay, it can be a possibility if the car is uh, of a very good brand or very good uh, industry brand. If it is a Ferrari, it can be possible, like it maintains the speed of that. So you can see a particular pattern. There is a pattern of scattering. Like there are you if you cannot draw any shape from this particular histogram. There are no shape like bell shape we have observed here. It is bell shaped. We have observed it like a building and boxes like shape here. but you cannot draw any shape here because it is scattered around the x and y axis. So that's why the name came uh, from here only, the dataset distribution only, that scattering of the data. So it is one way of representing the data also, because the data set which we are using have the values scattered around. So we are having the result as well, which is scattered around the graph. So it depends it you can infer two things here. You can infer that data set is a very important thing. Like if we are given the data set, uniform data set, then we can generate a uniform graph. And if you are having a ununiform data set, and if you are having a scattered values, so we would generate the histogram as well. The histogram would be scattered as well. So let's carry the discussion further. I don't think we need to any understanding about this code. Here we are using pipeplot as the same. We are importing the pipeplot module from this library, and we are using two arrays here. You can say a list here, and we are using we are using plt.scatter method. It is having two arrays, x and y. X represent from x-axis and y represent the y-axis, and we are calling the show function to show us the visual in the histogram. So after that, it is just the explanation of the of the previous example. So you can see the x-axis represent ages and the y-axis represent speed. What we can read from the diagram is that two fastest cars were both 2 years old and the slowest car was 12 years old. So this is just the observation. It can vary from different for a different example. If you are using a example of, suppose, a example of marks of student and the class of students, so it can vary as well. It is dependent upon the data set, I want just say. Yeah, so let's just take this example and show uh, okay, let's just include the plot dot show function. Can observe the values are scattered, but there are some values which are overlapping to each other, or which are having the same x and y axes. So it can happen because we are generating random values. See here, the random, we are using random method here, and we are generating a normal function, and we are using a scatter plot. So 5 is the mean value in the first x array, and 10 is the mean value. 1 is the standard deviation for the first array, and 2 is the standard deviation for the second array. And we are generating 1000 values in both the cases. And we are plotting it on the scatter plot from x to y axis. And we are showing it using the show function. So it is just like the same. If you want to change this values, the further graph would change, like you can see. And if you change this as well, let's see what happens if the data sets are sim. Yeah, the plot also changed according to the data set you are giving, or according to the values or parameters you are giving. So we covered that part, and let's come to hypothesis. Before hypothesis, I want to know if you have any doubt. The position are returned. Yeah, if you have any doubt, you can ask in the chat. I guess no doubt is there. Okay, so let's move on. So let's move on to hypothesis testing. So hypothesis testing, what is it is? It is basically the method that is used in stats. What it can do is we can draw inferences from a given population of data. Suppose two data sets to given to you, and you need to draw some inferences. Like someone asked me earlier, like what we can draw from this data set. So it is basically that it is something from where we can do the analytics part. We can draw the information what we are having, and what we are given on the uh, array or a list or a tuple, anything. So it is having two types, null hypothesis and alternative hypothesis. What is null hypothesis? It's typically states there are no significant difference. It means that there is no significant difference between the variables or the data set we are using. And alternative hypothesis represents that there is a significant difference. If there is a significant difference, so it can be represented in H1. And if there is no significant difference, it can be represented by H0. So in machine learning, hypothesis testing is often used in tasks such as comparing models. So you can use this in comparing your models, evaluating the significance of features, or testing the effectiveness. So when you are comparing anything, you need to when you are comparing anything, what can be the values you can infer? Can anyone answer? What would be the values if you are comparing two things? Like Ram is bigger than Shyam. What can you infer from this? What would be your answer? Ram, but I want a particular keyword for that. If Ram is greater than Shyam, if 5 is greater than 10, then what you can infer from this statement? 5 is greater than 10. What you can say is 5 is greater than 10. I want that one word. Yeah, exactly. True or false, you can say. Yeah, true and false. If 5 is greater than, it would be false, obviously. But I I wanted to ask that only. Yeah, what you can infer from this statement. So here also we are having the same thing. So if there is no significant difference, so we are keeping this in null hypothesis as 0, and if there are significant difference, we are keeping this in alternative hypothesis. So I have written a big program also. It is a quite big program. I will explain it to you also. So first, let us first run this program and see what happens after running it. Um, 1 second. Yeah. I have given comments also. If someone is you, if someone wants the PPT, the team would share the PPT, and if in further days you want to understand these things, there are comments given so that you can understand it well. Okay, let us run this code. Okay, so here the problem occurs. Hmm, are there any further comments? Okay, let's run again. Yeah, uh, it occurs because the comments are in different lines, so the indentations are bad at there. So we can do from here as well. Like we are having two type of groups, and we can just predict whether it is a reject null hypothesis or it fails to reject null hypothesis. So we can copy this and run it here. Um, Output is correct. So what happens? My bad. It was I just made a simple mistake on copy pasting. I forgot about the indentation. Okay, no issues. So what we can draw the from the data set given to us here. So we can see that the output is reject null hypothesis. There is a significant difference between the groups. How we can see that? Let us see the group one first. Let us zoom it and see the group one. It is having 80 as a mean value, 10 as a standard deviation, and 100 as the size. And group 2 is having 85 as a mean value, 12 as a standard deviation, and 100 as the size. Okay, so we can by our common sense we can say that the values are differing from each other. So the answer would be reject null hypothesis. There is a significant difference. What happens if we change the values to 80 and here we changed it to 10? Here both the data sets are same. So let's check. It says where we have changed. Yeah, let us run this one. Yeah. Here we can see that it says fail to reject null hypothesis. There is no significant difference between the group as we are using 80 and 10 and 100. These all are same. Yeah, 100 here doesn't matter, but the mean and the standard deviation are same. So it is saying that there is no significant difference between the groups, and we can assume it as a null hypothesis. And if it is not same, so we can assume it as an alternative hypothesis. So this is what hypothesis testing is. So let me let me tell you about the code. So we are having NumPy as our library, and we are importing this test t-test as well, and t-stat and p-value for our groups, and we are printing that using statistics t-stat and p-value, and we are having p-values less than 0.05. If it is, so it's a reject null hypothesis, and else part we are having fail to reject null hypothesis. So this is what the code is, and let me check if you have any doubt. Okay, so let's come to our last topic. Yeah, probability distribution. So probability distribution is also a representation, and it not a representation. It basically tells about the basically occurrences of the outcome that can be that can be there in any experiment. The chances of a particular outcome to occur in a particular experiment. You can say uh, in a easy language. And in machine learning, probability distribution are fundamental for modeling uncertainty, generating random samples. Yeah, you can use probability for that as well, and defining probabilistic models. So there are three distribution comes under which comes under this probability distribution. So these are normal distribution, Gaussian distribution, binomial. Like this one we have read earlier in this session also, binomial distribution, and Poisson's distribution. So what these all are? So normal distribution represents a symmetrical bell-shaped curve, like we discussed and saw earlier, and defined by its mean and standard deviation. Yeah, it deals with mean and standard deviation, and widely used in statistical analysis and modeling. Okay, so we have encountered this. So I am not taking it further. So we are starting from binomial and Poisson. So what does binomial means? It represents the number of successes in a fixed number of independent trials. So suppose we are having a particular data set, and we are using the data set for generating the outcomes. So it represent the binomial distribution would give you the number of successes. Means like suppose let us take one example of the tossing of 2 coins. Okay, so here I am taking an array, or you can say list toss, and here I am storing head, 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 tail, tail, head, and tail, tail. So can anyone say the probability of occurrence of head, head? Can anyone say the answer here? What would be the probability of occurrence of two heads in this data set? I would also give you the clue. Total number of data sets are four. Okay. And you just need to figure out what is your possibility of occurring of head-head. Let's see the chat. Okay, one is typing 25%. Okay, let's see other what is it correct or not. Any further answer anyone wants to give? Okay, 25 is the correct answer. So well done. So here, yeah, 25 is the correct answer because 25% of the occurrence are reserved for head-head and other this as for every individual outcome there are 25%. So it's a very easy question to anyone. So suppose if we are representing these two heads as our successes, so the binomial distribution would show the date would show the data according to these successes only. That is what I mean to say. Okay, it is defined by the parameter number of trials and probability of success. Like I said, if you are having like here the trials are head 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 tail tail head tail tail, so the number of trials would represent 4 and the probability of success. So here we are assuming here we are assuming head head as our success. Anyone can assume anything. If suppose someone wants to assume head tail as his or her success, so it is it is for that person, it is dependent to that person. So it can be changed or altered. So for me it is head head is a success, so I am assuming head head as my possibility or the success thing. And the binomial distribution would say the same if I'm assuming this. So it would be giving me a histogram or any particular visual according to this only. So let's move on to the Poisson distribution. The Poisson distribution represents the number of events occurring in a fixed interval of time or space. So it represents the events happening in a fixed interval of time, like from time 0 to time 10, or what much events happened, it represents that. From time 10 to time 20, how much events happened, it represents that. So it is defined by the rate parameter lambda, and here lambda represent average number of events per interval. Like what are the uh, so let me ask you one thing. So suppose 10 events occur from time, uh, let's say time equal to 1. Both are inclusive. Okay, so can anyone say the average, like this time and this time is inclusive? Can anyone say the average of occurring of this? Like 10 events are occurring from time 1 to time equal to 5. What we do the average you can you can draw from here. The answer lies here only, the average number of events per interval. So time interval I have given you this, and in every event, every interval there are 10 events. So what would be the average? It is a very easy question. You can answer 2.7. I don't think it is 2.7. 50 events total. No, it is not 50. See, I think you didn't understand the question. Like, if there are 10 events occurring in every interval, so what would be the amount of average event occurring from time 1 to time 5? it would be 10 only because 10 events are occurring at every interval and time interval is time 1 to time 5. So what is the average for every interval? It is 10. Yeah, it is a little bit confusing. Okay, no issues. Let's move on. Let's check this code. It's a let's understand this code. Uh, yeah, don't just punish me if this code gives an error. Yeah, it will give an error because the indentation is not followed. Oh, it doesn't give an error. So here we can see the normal distribution curve. So for this particular probability distribution, I have used the normal distribution as an example because I want to because for previous in the previous of this session I have taught you about the normal distribution, so I have taken this example also. There will be a homework for you guys. You come up with binomial distribution code and Poisson distribution code, and you can just write in the Discord general section that you have made this code or you have written this code. You can take the examples of AI, chat gpt or anything, but just understand the code and let us know about the code. Let me explain you this code. So here we are having first the this import libraries and all, and we are fixing the values of mu. Mu means mean to 0 and sigma means standard deviation to 1. And we are generating a normal distribution from this function np dot random dot normal. See here we are using np as our convention. Dot random means it will generate non random values, and normal means we are dealing with the normal distribution dataset. So mu is the mean, sigma is 1 and mu is 0, and 1000 is the amount of values that we want to generate. So we are plotting histogram here. Here data represent this thing. Beans means uh beans, you can say beans are the this lines, this particular lines which are represented by the histogram. And density true, alpha 0.6. This you don't need to understand now as these are advanced topic. So we are just sticking to that. We just want to observe what happens to when we just run this program. So let's see. There is a bell like structure. Okay, so the bell-like structure, see, while levels means the probability density, the occurring of this much outcomes, and x-axis is the values. So zero values, the occurrence of zero is, you can assume here zero is below 0.40, and the occurrence of 1 you can see greater than 0.25 and lesser than 0.30. So from this you can draw that how probability would be calculated from using the probability distribution and using this code. So is there any questions from the topic which I have covered, from percentile, from data distribution, and the last one probability distribution? Is there anything you want to ask? Have you, Khushi, Soumyadeep, the guys, those who are here, have you understand? Just can you please write in the chat box so that I would be known to it? Okay, so there are some part left in this session that would be covered by Tisha from here. Actually, actually we are having this thing, hypothesis testing and probability distribution. That is because Tisha stopped, and Tisha would explain this means the further part using this which I have explained. So That's why we have interchanged the speakings. So, the Tisha, are you there?
Yeah, hi everyone. Hi Aditya. So, guys, we are left with just one topic, which is actually covering hypothesis as well. So, it's like not necessary for you to know hypothesis, but it's good if you know hypothesis. That's why we actually skipped that topic and dived into all the topics that Aditya has covered. I We hope the topics that are discussed till now are crystal clear to all. So if you guys are good to go, let's dive into the other topic.
Okay, so Tisha, you can take it from here. Thank you, everyone.
Yeah, thanks, Aditya. Aditya, can you just unshare? Yeah. Okay, guys. So let me share my screen. So, guys, we are left with Bayes theorem. Is my screen visible to all of you? It's visible. Okay, so we are left with Bayes' theorem, where we have a word named as hypothesis as well. But we will not be diving deep into hypothesis. I hope you actually know the meaning of what hypothesis is. We will be just having a word here named as hypothesis, so you just know the background of it. We will not be deep diving into that. So it's like very simple thing. What is Bayes' theorem? So Bayes' theorem describes the probability of an event based on prior knowledge of conditions that might be related to the event. It is based on conditional probability. Now we have already dealt with these terms when we were dealing with probability theory or probabilitics when we were in our schools, maybe or maybe not with your case. So let me just brush up with all these topics. So main two words that we will be dealing in this session will be conditional probability and marginal probability. So when we talk about conditional probability, it is one of the types of probability in probability theory, where the probability of one event is dependent on the other event which has already happened. So that this type of probability is known as conditional probability. But when we talk about marginal probability, so in machine learning, marginal probability is the probability of an event for one random variable regardless of the outcome of another random variable. So you might not be clear with this meanings of conditional and marginal probability, but I hope you have a bit grasp of what conditional probability is. Like conditional probability is we are already having prior knowledge of the event. In marginal probability, we are dealing with random variable regardless of the outcome of the another random variable. So it's like the basics that we will be covering in Bayes theorem. So it is based on conditional probability. It means that we are already having the prior knowledge of the events, and we will be dealing with it to take out the probability of the new events. Okay. So in probability theory, it relates the conditional probability and marginal probabilities of a random event. Okay. So as we have said, like there will be random event that we have to take out the probability of. So we will be actually using conditional probability, and we will be dealing with the new probability that we have to take out. So in machine learning, Bayes theorem is often used in the context of Bayesian inference, where it enables us to update our beliefs about the probability of a hypothesis given new evidence. So I guess this 2 3 lines will be clear when we are dealing. We will be knowing the formula of Bayes theorem. So I guess you can just go through with this theory when we are done with the formula. So Bayes theorem is a fundamental concept in probability theory, widely used in machine learning for classification, anomaly detection, and probabilistic inference tasks. So what is Bayes theorem? So this is the Bayes theorem, which is probability of A when B is given. This can be find out if we multiply probability of B when A is given, and the probability of A divided by probability of B. But what are these terms? So like A and PB are the probabilities of event A and B, and also PB will never be equal to 0, which is because this is in the denominator. PAB is the probability of event A when event B has already happened. B a probability of B PBA is probability of event B when A has already happened. Okay, so I guess you are good to go with the formula. So I guess you will be going to understand this particular statement after knowing the whole derivation. So here's the derivation. So Bayes theorem. So we are dealing. What is conditional probability here? So when we are simply having H slash E, probability of H slash E, which is equal to number of times. Just a second. Okay. So probability of H slash E is number of times H and E by number of times E. This we already know. So this is conditional probability actually, and that this can be represented as PH. Uh, this is like uh, this is the and function that we know that we use E H H E, and by this is by probability of E. So here H is represented as hypothesis and E is actually evidence, because we are already knowing the probability of E, and through which we are actually taking out the probability of H. So that is why it is known as HE. Okay. So what is the theorem? So theorem, it is the way to calculate PAB with the knowledge of PBA. Here in the formula, you can just say this is the we are already having the knowledge of PBA, and we are going to take out PAB. Okay, so this is the theorem. So how we can derive this is PA and B. We already know the conditional probability. So when we talk about PA and B, means P and AND operation and E. So A and B. So it will be PA B by into PA. So here you can see PAB into PB. Here it will be PB, sorry. It's like EA is there. So here will be PB, AB, and here will be PB. So it when we will be taking out PA and B, so it will be PA slash B into PB. Here you can see the first derivation as the same, and similarly when we will be taking out PBA, sorry, here's the mistake, it will be PBA. So when we will taking out PBA, so it will be like this, and this will be the from first and second equation we will be getting this thing, which is because sorry, PAB can be represented as PBA into PA as well, because if we are already having knowledge of this particular thing, like if B is given and when we are already having the knowledge of A, but P is and we are going to take out probability of B. So that can be also considered in the same equation, and it can be represented like this. Let's say PBA into PA. I hope that is clear. And this both situation can be this both equation can be equalized to each other. This is how it will be. And then we have to just do the shifting, which is we are going to take out PAB in the left section, and we will be shifting PB here. So here, PA is going to be prior probability. That is probability of hypothesis. Means we will be already knowing the PA. And when we talk about PBA, this is actually likelihood. That is probability of evidence. That is like we will be already having the evidence of what we are taking up in charge. And then we talk about PB, which is PB is marginal probability, probability of evidence, which we will be taking out actually, and which means we have to take out from whatever information is already mentioned. And this PAB is something that we have to find out using this formula, which is posterior probability, probability of A when B is true. So this is the formula, and let's quickly dive into the code. Now, I guess you will be able to understand the formula easily, because there might be a lot of confusion right now. But let's dive into the formula. So let's just take a situation here. So here is the T disease, which is 0.01. What is this? This is the prior probability of the disease. Means this is PA. We are already having the let's say we are taking something medical conditions in charge, and we are taking out the probability of that disease. So probability of that disease is 0.01, and which is considered as a prior probability, that we already know that the probability of this disease being happening is 0.01. So this will be prior probability, which is pa. So in this formula we already know the pa, which is p disease here. Then the second thing we have is p positive given disease. Means this is the probability of positive test given the patient has the disease. So we are already having the data of that the patient is having the disease, and then we are taking out the probability of the positive test out of it. So this particular statement complete is considered as pba. Here a is what? A will be the patient has the disease, and pb, b is what? The positive test. Okay. And let, like you know, here this is the pba, means this thing over here in the formula, pba. Now you can just predict what will be pab. Pab will be probability of having a disease given a positive test. You can compare these two statements and you will get to know what is the difference between pab and pba. So this is PBA, that we are already knowing the patient has the disease, and we are actually going to that patient has a disease. This is the true thing, and we are actually taking out the probability of a positive test out of it. But what PAB will stand for? That given that a positive test is there, and what is the chances? What is the probability of patient having the disease? Okay. So this is what we have to take out. This is PAB, this is PBA. So now from the formula you know that we are already knowing PA and PBA in the in the uh, upper part of this formula. We already know the values, which is zero point 0.1 and 0.99. Now what is this? This is P positive given no disease. This is the probability of having a disease. This is a probability of not having the disease. The patient is not having the disease. Okay. So this is 0.05. This is but from this all data is going to be given to us. This is like prior knowledge, or like this, all this data is given to us, and from that we are going to calculate what probability of having the disease given a positive test. So how we are going to do this? Firstly, we have to take out the PB, which is the marginal probability. So how we are going to take out PB? So I guess you can just whatever I have explained just now, the variables that we have used are already here written in the full explanation, so that you are able to understand each one of it. Just a second. So here, P disease is what I have already explained. P positive given disease, P positive given no disease. So this represents the probability of getting a positive test result, given that the patient does not have the disease. Now, what is P positive that we are calculating over here? P positive is what? P positive is actually PB in the denominator. That we want to calculate. So, what is P positive? This calculates the total probability of getting a positive test result. So total probability of getting the positive test result. So positive test here, of course, you know, this was PBA. So positive test is considered as B here, and the disease is here considered as A here. So total probability of having the positive test is considered as P positive, which is PB. Okay. So it's computed by adding the probability of getting a positive result given the patient has the disease, and the probability of getting a positive result given the patient does not have the disease. We already know that a patient, we are having two probabilities here, that the patient is having the disease and patient is not having the disease. So we are going to actually use these two information, and these are going to be add up, weighted by the respective probabilities of having and not having the disease. So here you can see we are using two things, which is P positive given disease, which was here which was PBA, and P positive given no disease, which was this third information. So P positive sorry. So P positive given disease, when the patient is having the disease, it is raised by, just a second, guys. Okay, sorry for the disturbance. So P disease here is EA. So here, if the patient, the prior probability that we are already having is being multiplied by the uh, probability of that the patient has the disease directly. When the patient does not has a disease, so then we are subtracting this probability of prior probability that we are having from the one. Why? Because the probability won't be more than one, you already know, and the leftover probability can be find out by just subtracting one minus the whatever probability we are having right now, which is of that the patient has a disease. Okay, so 1 minus P disease will be there. So we will, by using this formula, we will actually get PB here, which is P positive. And then what we have to take out, I guess I've already explained this, that here we are taking out P positive given diseases. Like we already know the diseases, and we are taking out what's the probability of having the positive, which is PBA. So what we have to take out, which is PAB. So just disease and positive will get interchange here. So P disease given positive, we have to take out this, and this is the formula, which is the I guess this Bayes theorem formula that we are applying here. So we this is the PAB, this is PBA, which is P positive given disease, and this is PA, which is P disease, that the prior knowledge that we were already having, that the probability of the diseases. So this is PA, and in the denominator we have P positive that we have just calculated here. Then just we are going to print out this formula. So let me run this code. The output is this thing. You can also try this by calculating over here and just cross check the whatever outcome is being coming as the outcome over here. So here's the whole explanation of whatever I explained just now. If you are still not able to figure it out, you can just go through with it and just let me know if there's any doubt. And what's the application of Bayes theorems? Lastly, this is so Bayesian inference is very important and has found application in various activities, including medicine, science, philosophy, engineering, sports, law, etc. And Bayesian inference is directly derived from Bayes theorem. Example: Bayes theorem defines the accuracy of the medical test by taking into account how likely a person is to have a disease and what is the overall accuracy of the test. So when we're dealing with medical tests and the accuracy of the test, we need to take out all those things. So in these topics, it's very important to know Bayes theorem, and you are able to figure this out. If you will practice this particular code, just you will just write this code for 2 times, you will get to used to it what Bayes theorem is, and you can apply this theorem to other models that you are creating or you are actually dealing with right now. Or you can make another type of model uh, just using this Bayes theorem and actually predicting something which is very useful in the medical field. So I hope you guys are clear with the Bayes theorem. Let me know if you have any doubt in this particular topic. It's a bit confusing at the start, but you will just get to know if you have practiced just for 1 or 2 times. You will get to know, and be used to it. This. Let me know in the chat if you guys are clear with the theorem, or if you have any doubt, you can just ask in the chat section. Okay, there's a positive response that it's clear. Okay, guys, this notes with you. We will be sharing this notes with you after the session. You can just check out the GitHub repository that we have already shared with you. We'll be uploading each and everything of today's session as well by tonight or by the morning. So you can just get the update from the GitHub repository. And if you have any doubt, you can just drop your doubt in the doubts section. Let us know, and we'll be coming up with a solution as soon as possible. If you guys still have doubts, you can just send your doubts in the chat sections We are available for 2 minutes more. Okay, so it's clear to each and everyone. There's no doubt. So let us end the session today. We hope you guys got to know a lot of things today. We will be very happy if you just fill out the feedback form that we have shared with you. Let me reshare it once again. Guys, we have shared the feedback form in the chat. The guys who were actually there in the second session as well are requested to just fill out the second session, the feedback form for the second session as well. We have a filtration of selecting the session that we are taking. So select the session and give us the feedback for the same. It actually helps us to improve our sessions and that we are going to deal in the future. So make sure that's like if you just take just 2-3 minutes of your time and just make that time to fill out the feedback form. That will be very helpful for our team to improve in the future. Thank you so much everyone for joining us.